Chapter 10, Applications of Differentiation. 10.1, Extremum Problems. Okay, this is objective for this lecture. Okay, to find the critical points, to find the relative extremum using the first derivative s, to find the relative extremum using the second derivative s, and to solve optimization problems. So, critical point. What is critical point? Critical function f of x has a critical value at x equals c if we have two conditions. First, f of c is defined and f prime of c is equal to 0 or f prime of c is not defined. The point c, f of c is called a critical point. Okay? And so for stationary point, the point where f prime of x is equal to 0, or we call this one is dy dx is equal to 0 at the point x is equal to c. Okay, f prime of c is equal to 0. So, okay, this is that one, the graph. Okay, look at A. Here at A, dy dx is equal to 0. And then at B also, dy dx is equal to 0. C, dy dx is equal to 0. And but for D, dy dx is not equal to 0. So we can conclude that A, B, C all stationary points. Why? Because of the slope, the gradient. Okay, dy dx, tangent dy dx is equal to 0. Okay, and conclusion for this part, critical point when confirm f of c is defined. Okay, at this point, the function is defined, and find the first derivative f prime of c is equal to 0. Next one is critical point and also stationary point. Okay, when f prime of c is not defined, this is called critical point. Okay, for this one is critical and stationary, but for this one only critical point. Okay, and look at the example. Example 1, find the critical points of y equals, okay, cube root of x squared minus 1. Okay, and then first to find the critical point, first thing, okay, find the first derivative. Y is equal to x squared minus 1 power of 1 over 3 dy dx is equal to our rule 1 over 3 minus 1 is equal to negative 2 over 3, and write whatever in the bracket. Okay, x squared minus 1. Then the next is you need to differentiate what is in the bracket. That is 2x. So make it simpler. Okay, this one is equal to 2x over 3 x squared minus 1. This one is power of 2 over 3 and negative bring down. So negative is missing. Okay, and then so when to find the critical point and also stationary point, and dy dx is equal to 0. Okay, and dy dx is equal to 0. Okay, it implies that 2x over 3x squared minus 1 to the power of 2 over 3 is equal to 0. Okay, so this one is equal to 0. Okay, so 2x is equal to 0, or therefore x is equal to 0. Okay, so when x is equal to 0, substitute y. Okay, substitute here. Okay, 0 squared minus 1 power is equal to -1. Okay, -1. Therefore, 0, -1 is a critical point and also stationary point. Okay. Okay. Next step is, okay, this is still not done because we need to find critical point. Okay. So critical point when dy dx is equal to 0, same like this, and also when f prime x or dy dx is not defined. Okay, we try to find the second part. Okay, the first part already done. So to find the second part is take this one, dy dx. Okay, when f prime x is not defined, f prime x is not defined when this one, consider the denominator equal to 0. Okay. Okay, this one means, okay, look at this one first. Okay, so the dy dx is equal to 2x over 3 x squared minus 1 to the power of 2 over 3. So it's not defined. Okay, here. Okay, f prime x is not defined. Not defined when 3x squared minus 1 to the power 2 over 3 is equal to 0. Okay, when this one is equal to 0, 2x over 0, the dy dx is undefined. Means f prime of x is undefined. Okay, so taking this, okay, fine. Okay, implies that x squared minus 1 is equal to 0. Okay, quadratic, factorize quadratic. The x is equal to 1 or x is equal to -1. So we have two values for x. When x is equal to 1 and when x is equal to -1. Substitute, okay, into the function. The function is y is equal to x squared minus 1 to the power of 1 over 3. Substitute y. We try to find y. We want to find point. Means we want to find x, y. Okay. And substitute into y. When x is equal to 1, y is equal to 1 squared minus 1. Okay, is equal to 0. This one confirm 0. When x is equal to -1, y equals -1 squared minus 1 power 1 over 3, also 0. Okay, so the critical point, okay, there is 1, 0, -1, 0. So therefore, implies that the critical point are, okay, before this we try to find the first one. The first one is 0, -1, okay, 1, 0, and -1, 0. Okay, this one, okay, is critical point and also stationary point. Okay, critical and also stationary point. Okay, so this one only, the two one only critical points. Okay, done for example 1. Example 2. Find the stationary points for y equals x cubed minus 3x squared plus 6. Okay, to find the stationary points, okay, still you need to find the first derivative. You need to find dy dx. When dy dx is equal to 0, we can find stationary points. Okay, from the given function y is equal to x cubed minus 3x squared plus 6, differentiate y with respect to x, so 3x squared minus 6x. Okay, to find the critical stationary point, so it implies that dy dx is equal to 0. So take this one. Okay, 3x squared minus 6x is equal to 0. Factorize. 3x minus 2 is equal to 0. Therefore, x is equal to 0 or x is equal to 2. Okay, we have two values for x. Now, to find the point, we find the partner. That is point. When x is equal to 0, x is equal to 2. Substitute y 0 minus 0 plus 6 and y is equal to 6. 0, 6. Okay, 0, 6, one of the stationary point. And another one is y. Okay, substitute. Okay, and find that one. 8 minus 12 plus 4. Okay, so the answer is 2. Okay, so the second point is 2. Okay, therefore, okay, stationary point, stationary points are 0, 6 and 2, 2. Set for example 2. Okay. Okay, types of stationary points. Stationary points when f prime of x is equal to 0 or dy dx is equal to 0. So, stationary points, okay, for your level, just concentrate on maximum point and minimum points. These two called extremum points. Okay. So either maximum or minimum, that is at your level, okay, in the syllabus. Okay, and then okay, look at the steps to find extremum point. Steps to find: first, find critical or stationary point by taking f prime of x is equal to 0. Okay, and the second is test. You have two tests. Choose one, whether to test using first derivative or using the second derivative test. It depends on the question or function given. Okay, and then here actually, okay, stationary point. Okay, when dy dx is equal to 0 or f prime of x is equal to 0. First thing is you need to find each one. Differentiate the function to the up to first derivative. Find dy dx and test using the first derivative dy dx or dy dx square. Okay. For first derivative test, okay, relative maximum point. Okay, the graph is set graph. Okay, set graph. Okay, dy dx is equal to 0 when x is equal to c. So here, okay, at point c f of c, this one is on the top here. That is maximum. At this one, this area, this is maximum. So we can say that the point is relative maximum or local maximum. Okay, at this part only, this one is maximum. Okay, maybe the part of the graph is still that one is still has another maximum. Okay, and it happened when check the interval, the graph. Okay, when the graph is when C, this is C, when S is equal to C. Okay, when S less than C, okay, the graph is or dy dx is increase, and y increase. When x more than C, dy dx or y decrease, and y decrease, or the graph is set graph. Okay, smile set graph, and this one called maximum relative maximum point. Okay, for the relative minimum point, the graph looks like this. Okay, dy dx is equal to 0 when set x is equal to C, and the graph is something like smiling graph. Okay, this is C at C. Okay, when x less than C on the left, the graph is decrease. And the graph is decrease. When x more than C, the graph is increase, or dy dx more than 0. This one is minimum, relative minimum or local minimum. Okay, so using the table, okay, first derivative test. Okay, this is C. C, if you do number line, this is C. Okay, and this is plus or minus lah. This is more than C, less than C. Okay, x less than C, x greater than C. Okay, for f prime of x, okay, it's a positive increase, decrease, or the graph is the gradient is increasing, decrease, decrease. So this is maximum. Here is maximum. We can say this point is maximum point. Okay, when this one for f prime of x, when x less than C, the graph is decrease. Okay, the graph is decrease like this, and then when for x more than C, the graph increase. So this is the minimum point. Okay, minimum. So you can, from the table, you can mean maximum or minimum that point. Okay, for the second test, using the second derivative. When given y is equal to f of x and differentiate, find f prime, and substitute C, and that gets 0. Or dy dx is equal to 0 when x is equal to C. Then find f double prime of x exists on an open interval contain C. So find the second derivative. And the second derivative exists. Let's say something value, and we can say f of C is called an extremum value. And extremum value may be minimum or maximum. Maybe minimum or maximum. So now, okay, we check the value of the second derivative. Okay, if the second derivative d2y dx squared less than 0 or negative at x is equal to C, now the point is called relative maximum. The relative maximum, when that one is less, okay, second derivative less than 0, okay, this one is called, the point called maximum, local maximum or relative maximum. And then when the second derivative is positive, more than 0, positive, at x is equal to C, then this point is a relative minimum. Okay, more than positive, minimum, negative, maximum. Okay, don't confuse. Okay, negative, maximum, positive, minimum. Okay, then okay, the graph is actually this one set graph, smiley graph. Up to you. Okay, just remember that when dy dx squared negative, this part is maximum. The point is maximum. When d2y dx squared positive, this graph, this point is minimum. Okay, and example 3. Find the relative extremum points for y equals x cubed minus 3x squared plus 6 by using first and second derivative tests. Solution, we need to differentiate this function. y is equal to x cubed minus 3x squared plus 6. We differentiate y with respect to x. 3x squared minus 6x. Okay, so to find the extremum, okay, and we find when dy dx is equal to 0. Okay, so when dy dx is equal to 0, it implies that 3x squared minus 6x is equal to 0. Okay, factorize. And then x is equal to 0, x is equal to 2. Two values for x. And because let's say that points, here is points, you need to find y value. Okay, points. Okay, value. This point is that you need to find x and y. So when x is equal to 0, substitute y is equal to 0 minus 0 plus 6. Y is equal to 6. So this point is 0, 6. Okay. When x is equal to 2, okay, y, okay, 2 cubed minus 2, 2 squared plus 6. The answer is 2, right? Okay, point is 2, 2. This is the same example. Okay. Like the first example again, okay, and then you need to test at this point whether maximum or minimum. Okay, at this point, maximum or minimum using first and second derivative. Let's say you have two values of x. Just do one number line. Okay, here is 0 to this is infinity, negative infinity. Just write this one. Okay, and then this is the value for x. Okay, value for dy dx and the graph. Okay, the method of the graph, is it increasing or decreasing? Okay, and this is actually take one number value here, or you can write down negative infinity 0, right? Negative infinity 0 to infinity. This one just ignore, okay, or you can write the value. So just take one value here. Okay, let's say this is negative 1. Substitute to the dy dx. Dy dx is equal to this one. Or you can take factorize. Let's say factorize. Factorize dy dx is equal to 3x x minus 2. Okay, substitute negative 3, negative 1, negative 1 minus 2, negative times negative, positive. Okay, or substitute inside this one. Okay, and for 0 from the right, let's say here is 1 or 0.1. Okay, substitute 3 times 1, 1, positive. 1 minus 2, negative. Positive times negative. And choose one more. Okay, 2 from right, select 3. 2.1 actually. 1. Substitute positive and positive. Okay, and the graph actually this one is positive, so increase decrease, increase. The gradient, the graph increase. Why? Because of this one is positive, increase, and decrease because of the one is negative, and increase positive. So at this point, okay, here at 0, okay, this point is maximum. When s is equal to 2, this point is minimum. Okay, minimum. So can make a conclusion. Okay, at point 0, 6, this one is 0, 0, and this one 0, 6. This graph is a relative, okay, relative maximum. Okay, and then maximum points. Okay, and then for 2 to this point is a relative minimum points. Okay, settle using the first derivative. Okay, for the second derivative, okay, means you need to find d2y dx squared. This one continue differentiate 6x minus 6 and substitute when x is equal to 0, d2y dx squared equal to negative 6. When x is equal to 2, d2y dx squared is equal to substitute 6 times 2, 12, plus minus 6 is positive. Okay, so you have to write, oh, this is less than 0, more than 0. Okay, you have to do this, right? This is 6, negative 6 is less than 0, positive 6 is more than 0, and make a conclusion. The conclusion is this one is less, dy dx negative. Negative means this one is maximum. This one positive, this one is minimum. Okay, minimum. Then conclude same like this one. This one 0, 6.06 is a relative maximum. Okay, 0.6 is a relative maximum point, and 2 is a relative minimum point. So the first is this one using the first derivative, okay, table, and this one is using the second derivative. Okay, example 3. Okay, let's say okay, you just write down here actually 0. So okay, and then the graph, okay, increase, decrease, and actually this one is increase, decrease, increase. So okay, maximum, and this one is minimum. For the second derivative, differentiate for the second derivative. Okay, then substitute the value of s equals 0, then get negative. When s is equal to 2, okay, d2y dx squared positive. Okay, you have to write okay, you have to mention this is more than 0, less than 0. Okay, and conclusion. Okay, this is the conclusion. So make sure relative. Okay, maximum. Why? Because of, let's say, maybe the graph is like this. Okay, the graph, okay, maybe like this. Okay. Okay. So here actually at this area, only as this area and this area. So at this point, this is maximum. here, maximum, relative maximum. It's only this part, this area, this point is maximum, local maximum or relative maximum. At this part is minimum, so local minimum. Here also local minimum, relative minimum. So but the graph stay from the negative if this is, we don't know the value of minimum. Okay, so but at this area only, we know that this is minimum at this point. Minimum at this point. Okay, what we call relative. So that's all for this lecture.